In the next 30-40 minutes, we're going to talk about in-memory NoSQL. And we're going to see some options you have if you want to start using it. And first we can, okay, just to start it. Okay, so just a few things about myself. I'm a technical guy, but that's my, I think, a little more fancy than to say that I'm a geek. That's my email, my Twitter account, and my Stack Overflow user. And of course, I expect you to remember it, but not the numbers or the user. It has some meaning in this context of the presentation because it's actually a Redis key. This is how the Redis community uses this convention of putting a colon, and this is a Redis key. Now currently I'm doing software for the travel industry. I'm working at this company, filling the position of CTO, PlugAnd Travel. PlugAnd Travel is actually just a brand, that's why the name is actually Bees Pro Technologies, you saw on the paper. And we are doing a travel platform, and we're selling it to travel agencies, so we're in the B2B marketplace, going to the travel shows all over the world and connecting all sorts of companies. We have startups, and we also have big companies doing thousands of reservations per day. And I don't know if you have friends or if you want to start a business in the travel industry, feel free to contact us, and we have solutions. Okay, so this is the context. This is the context where we use these solutions. And so what means to run things in memory? I mean, what is in memory? Why would you need something to be in memory? Now, first thing that comes to mind when we talk about in memory is performance. I mean, we make a normal connection that accessing RAM is fast while accessing the disk is slow. It has a very big latency. So it's high performance, but it's not only this. If you think about it, in memory it's a key point to having a scalable application. If you think of all the big applications of today, they all use like some caching layer, and it's probably one of those free servers out there. And just take that caching layer down, and they will probably collapse under the load of all their requests, all their clients, all like this. And for example, all Twitter timeline is kept in Redis. They have their own Redis fork for now. Maybe they will share with us later. Facebook uses Memcached a lot. You can find talks on the internet on how they are reloading data, scaling old data, and stuff like this. Very interesting talks. And Stack Overflow uses Redis. We all like it. We all like to use Stack Overflow. So just think about it. If you take all these caching layers down, they will probably stop working. Now, walking down this scalability path, this is how we started adopting some of the in-memory NoSQL solutions at the place that I'm working at, PlugAnd Travel. And a couple of years ago, we had clients that grew up, and we had to move them from one server to more servers. So we had to add one load balancer, and under the load balancer, we could put more machines. And of course, once you do that, you have some challenges. And because session was only on one machine, now you will need to have it on all the three. So it's kind of not possible. Cached items, I mean here something like search results. If you kept the search results in the process memory, now you have 2, 3, 5 machines. So you'll not have them on all the machines. Static items are like the things that you load when your application starts. You put some things in the process memory, so their application doesn't need to fetch them. So it's like a local cache. But now when you have 4 machines under load balancer, maybe it's not such a good idea loading them 4 times from the database. Maybe you want to have them only once somewhere. And I don't know, maybe 10 years ago, the solution would have been to use sticky sessions. Sticky session means on your first request puts a cookie on the request, and then the load balancer will know exactly to what server it will send you. So every time you get the load balancer sees the cookie, and it will know to send you to, I don't know, to which server you went the first time. And it's working. There are still a lot of companies using it. There were companies complaining a couple of years ago that sticky sessions wasn't available on the load balancer of Azure or something like this. So there are many companies that are still using it. But if you are on AWS, like we are, or on another cloud platform, you should aim for autoscaling. And autoscaling will not work with sticky sessions. Autoscaling means that you will adapt your capacity based on the load that you get. So, for example, in our case, because we're working with these travel agencies, like there are common places in the cities somewhere, they are open during the weekends. During the weekdays, and are closed during the weekends. So, like in the picture here, you can see that we get a lot of our traffic we get during the weekdays when these travel agencies are open, and during the weekends it's much less traffic. So we don't need the same capacity. So the idea is to also be able to reduce the number of machines. And if you reduce the number of machines, you'll not be able to use sticky session anymore, because that machine goes down with all its session, all its data that it's kept in memory. So for that, if you're going on, if you are on a cloud platform, you should aim for autoscaling, because if you're not doing it, you're using something a lot, actually. Now, I think I'm guessing here, but I think most of us are doing some web application, and you get stuff like from the client, and you store it in some database. Is it Oracle, SQL Server, and stuff like this? So every time you have a problem, you think of the database, it's the solution. Like if you need to store something, you're going to put it in the database. So it's really dangerous, but because this is what we are used to, you could think of storing the session, storing the search results in a common place, and that would be the database. But if you think about it, databases were not meant for this. I know that there are session providers for the main databases out there, so you can have I don't know, Node.js session stored in MySQL probably, or ASP.NET session stored in SQL Server, that's for sure. But you don't need your session to be stored on a disk somewhere and reloaded from a disk, and you don't need all the transactioning and all the ACID compliance and everything. You just need it to be fast available for you. The same with the search results and stuff like this. Storing them on the database and expiring them. These databases usually don't have a mechanism of expiring things. You need to do all sorts of things. So it's really not meant for this. Even though it's working, and I know companies that are using it. So another solution would be to use some in-memory NoSQL server. And we're going to see about these three guys here. And we're going to see why would you use one, because they were not all are general solutions. One is better for some things, and because they were all created with a specific problem in mind. Okay. So let's think that an in-memory solution, an in-memory NoSQL would be the solution to your scalability issue, to going to have a higher performance application. If you're going to suggest this to your team, to your manager, to the architecture group, club, whatever, they're going to have some questions. And I thought about it and I came up with 3 questions, and I'm not trying to give you the answers for them, but I'm trying to share some facts around those questions. So the first question which comes to mind if you pick some in memory NoSQL is if it's expensive. So now you're thinking about storing data in the RAM, and you know that price is much bigger than storing it on a disk. Doesn't even compare to SSDs. So probably you're going to get this question from your colleagues at least. So I can't say if it's expensive or not, but I can show you some numbers. And these are the prices you get for bare VM. So you don't. This doesn't include prices for licensing or stuff like this, or some clustering that is going to be held, I don't know, by the cloud provider. So these are the bare costs, starting from 1 cent and increasing a little on AWS and Azure. But where on AWS and Azure, and you have this option of going with an upfront payment. So you pay something at the beginning and you commit for a couple of years, 1 to 3 years, and then you get an hourly rate, which is cheaper. And what I also found interesting on AWS, if you're going to need it, it has like some huge machine with almost 2 terabytes of RAM. And if you calculate the price, is something like 0.7 cents per gigabyte RAM per hour. So it's a huge machine. I didn't see it in any other cloud provider. So I find it interesting that they're offering something like this, and there are clients using it. Now, a second question is, and probably a very important one, is what will happen on a restart. Now, it's possible that your VM will get restarted. You might need to upgrade your Redis installation. You might need to just restart for some operation, for some maintenance. So, of course, you know that the RAM is volatile, and on a restart, you're going to lose everything. So, how are you going to handle such a question from your colleagues? And let's say besides Memcached, which is actually just like a simple caching mechanism where you kind of expect not to find some things there, the other ones do have backups. So let's just say if you are planning some maintenance, just do a backup and you can restart the node, and it will automatically find that it has a backup, and once it's restarted, it will start getting all the data from there, and it will be available in a couple of minutes, depending on how much how big your backup was. Now, there is also this works in a situation where you know that you're going to do a restart, but you also have you might have the problem that VM might restart itself, or you might not find it anymore, or stuff like that, or you find that it already restarted. We saw some things like this on AWS. So, and for this, you can configure both Redis and Aerospike to have disk persistence. So every write that goes to the application, to the server memory, it will also be written on a disk. Of course, this will affect the performance. Writing on a disk, we know it's slower, but at least now you know that every time you have some operation going on, it will also be saved on the disk. And a much more interesting solution for this restart is that Redis supports like a replica set. So it's like the classic solution of slave and master. So you can deploy like a replica set with 2 slaves, and you should have no problem. There will be elected a new master. If your master goes down, there is a process, Redis Sentinel, that looks after that replica set. While Aerospike, it has a replication factor, so it's inside the cluster. data will replicate itself. It's also a common thing between many NoSQL solutions. Okay, so probably for this, it should be some combination of these three, maybe even all of them. So this should solve the problem of RAM volatility. And the third thing is, would you be able to scale? And the scaling would help you in the case when you are arriving at the maximum of your RAM. So you are at 80-90% of your RAM. So in that case, if you are running some SQL machine, you know that you can always add more disks to it. So you created other file groups on the SQL server, whatever other technology, and you just keep writing to them. So it's live, you can add more disks to the machine. But if you are here, you know that you cannot add more RAM without restarting the machine. So this will not work. And also, if you are getting more and more data now, so you want to add more nodes to process it. And both Redis and Aerospike support something like a server-side cluster. And on both cases, you can add machines live. So you will not have to take any of the nodes down or something like this. Just start one more node, and you'll add it to the cluster. On Redis, it will be a little more complicated because you need actually a whole replica set added. While on Aerospike, you just add one more node. Should be similar to the other nodes to have like the same performance, but yes, it can scale. So these were the main questions that I identified. Maybe you have more, so you can share them with us. Feel free to ask me anytime, anything. Maybe I'm saying some things that you don't agree. So, and now we're going to meet these three main characters, and they were all created with one problem in mind. So they're not like any general solution, and you'll see that they have advantages in some areas and maybe some disadvantages in some other areas. So you need to be aware of this when you pick one of them. We're going to start talking a little about Memcached. I'm not going to drill it down too much because it's already battle tested. I mean, there are a lot of companies using it. If Facebook can use it, and they are using it very aggressively, probably thousands of machines, if maybe even more. I can't think of the scale of Facebook. Then I think it will work for everyone. It has a very simple API, very easy to start. On AWS, it's still available as a platform, and you can have a client-side cluster, so not a server-side cluster, a client-side cluster in just a couple of clicks, and you can start it. And you can add more nodes, you can remove nodes, but with some data loss, which is okay because Memcached is just a simple cache layer, immutable, which means that you never think about it like I'm going to modify some value inside some key or something like this. You just work with the key, you expire a key, you get a key, delete a key, get multiple keys, something like this. So all the operations are key-based. You don't do something with the value inside there. You just get it and use it. So, and you do have you do need to be prepared that there might not be the key inside the server. It has this limitation, which I found it a little inconvenient because we're in 2016 now. And it's strange that it still has a value of maximum 1 megabyte. You can easily solve it by, I don't know, key underscore 1, key underscore 2, key underscore 3, something like this. So you can split like a big value into separate keys, but it could use, maybe, it could do this internally, something like this. Okay, so moving along, then we find out about Redis. And Redis was created with solving something like live analytics. This guy who started working on it was trying to write some live analytics in a MySQL database, and it's not that he was trying to write some big chunks of data, but he was trying to write small pieces, but very, very fast, very often. And he couldn't do it, and he came up with this solution. It's one of the great servers, in-memory servers out there. A lot of community attention around it. There are a lot of companies using it. All the Twitter timeline is in Redis, so if they can do it, I mean, it can work for everyone. It's really easy to start with. Even if you are developing on Windows, there is a Windows port, so you can install it like a service locally. You can develop on it. It's not for production, but just very easy to start. You have it as a Vagrant machine, and once you go live, on both AWS and Azure, you have it as a platform. So just a few clicks, and you have a replica set with high availability already running, and you could just connect your server to it and start using it. I think a lot of companies are like it just because it doesn't have any commercial, or at least yet, behind it. So everything is there. There is no community enterprise edition like we're going to see Aerospike. So that's why many companies like it. There are a lot of clients for probably all the languages used out there for connecting to Redis. It also has a probably all the clients are community based, so there's nothing created by Redis founders or something like this. So it gets a lot of attraction. But now when we move on with Redis and start reading a little bit more stuff about it, we will find that it's a single-threaded server, and this has advantages and some disadvantages. Because it was created with solving this live analytics in mind, it has a lot of data structures. So we'll find these data structures to be, I think, the main power of Redis. So once you understand them, you could really come up with some nice application. And my demo is going to be on these data structures, and we're going to see them a little bit later. Everyone now is offering scripting support in Lua. So it's not only Redis, it's Lua. It's a really nice language. It's C-like, so it's very easy to pick up and do just some small script and to run it on the server. So because if you just want to have real fast access to the data, you don't need to get it to the client and do some operations. You can run it already. You can run some script already on the server. You just need to be aware that being a single server threaded, there is no other request. There's only one thread that it's serving all the client's requests. So if you are blocking with some long-running processes in Lua, there's no other thread. All the other requests are queued and could lead to timeout. Initially, it started with just replica set, and they added now server-side cluster, I think, last year. So it is there. And we saw that it has persistence, like it has an append-only file, and exactly the command that you are sending, it's saved to that append-only file. It's not the data that is being saved. So the command gets written to a file, and if you restart it, it will start picking all the commands and pushing them to the server. And it can do snapshots of the data with backups. So now we're back at the data structures, and here we'll see a little bit about this in the next demo. Lists are not like the lists we are used to. Instead, they are double linked lists, so which makes them very good for inserting, but not good for moving along, finding some value. Sets and sorted sets are like unique list of data, and they are good for performing mathematical things like union, list, so these kind of operations for sets. And we'll see that if you understand how to use them, you can come up something like indexes, because there is no thing like secondary indexes. You need to create them yourself. And we'll see hashes that are similar to maps, but with only one level. So there are no only one level, no nested levels inside. Okay, so if you have some questions about Redis, about what I said so far, while I'm trying to start the application, please go ahead. So I have it installed like a service, just checking it's running, okay. No, actually I need here. So I have an application that it's only using Redis as its main database. So it's not using anything else for storing data. It's very similar to Stack Overflow, but of course not doing just a couple of things from there. So it has like users. It has like a user can post something, and then you can vote for that post. And I did it for some workshop that I held it a couple of months ago. It's very, and so you can find it here on GitHub if you want to take a look on it. Okay. Okay, started. So what I'm going to do is do some actions in this application, and then we're going to see exactly, we can monitor Redis and see exactly what command it gets sent to it. So we're going to create a user. It's very simple. Okay. And then something will happen here. So you can see the HM set, which actually means to set a value in a hash. And you can see the first one is the key of the hash, and you can see the convention used by the Redis community just to put columns between the values. This will be like the primary key of the row, if you think about like this. And then you have like columns, like subkeys, like first name, last name, city, country, job title, like this. And the values are following after. So this is what gets sent to the Redis server. Then there is a command pushing one value to a list. This is a list, last registered users. And it's pushing my email, which would be like the primary key, to a list. And it's L, it comes from left push, could be R, which is right push. And then it's trying to get all the items of such a list in order for me to display them here like last registered users. And 0, it's the starting index, -1 means that I want all the list. So for example, here I will try only to keep like the last 20 registered lists, so it's okay to use a list because it's going to be capped. It doesn't have this notion of capped lists, Redis. So I will need somehow to always truncate it myself. I need always to keep only the last 20. So here I would, if I would like to keep 20, I will need to put some other command to truncate it. Okay, something like this. So now that I have a list of at least one registered user, I'll create a post. Okay, so I have a new post. So let's see again what happened here. So you can see the starting from here. You can see again it's using like a hash to keep the posts. And then I'm using some more lists, and then this one I think it's new because this is the sorted list. So initially I'm putting I will post stop. I will keep here the top voted, and I will put here it doesn't have any votes, so it's 0, and then I will have some value to put in the sorted set, and I will have another sorted set for keeping all the posts. So if I want to keep something like all the posts that were created, so I would like to browse through them, I will not use a list. Instead I would use a sorted set, and this is the time when it was created, because with sorted sets is easy to move from one index to some other. Like say you have a page of showing 20 posts, so it's much faster than using a list. And here I am loading all the subkeys of this hash set, and then again you have using again the list. Okay, something like this, and then I can vote up. And once I vote up, you can see here, just a second, like this, you can see that the value was incremented by 1. So it's by 1, it's not the new value, it just gets incremented, this value. So now I will have 1 vote for the post that I created here. So I know it's quite a lot of stuff, but we can also talk about it after if you want to ask me more about the data structures inside Redis, because this is its main power. Once you get to understand these structures, you could utilize it at full speed. So if you have some questions, if not, then I will go on with it. Now, once you go live, you'll need to pay attention to some things, and mainly that it's a single-threaded server. And in our case, we learned that timeouts will happen. Being a single-threaded server and only one thread serving all the client requests, timeouts did occur in our case. So you just need to be used to it. Of course, you'll not leave things like this. So there is a command showing every command that will be sent to Redis. It will be analyzed, and all the commands that are taking a lot of time will be stored on some list internally, and then you could see it. see all which stuff made your server took more time to process. Even some commands that are in the Redis API, something like keys, which goes in the server and gets all the keys that are inside there and sends them to the client, or flush, which is just removing all the keys from the server, will affect your performance, and it will bring your master down, just because even if you have this sentinel process that pings the master from time to time, it's also on the same thread that it's serving all the other clients. So if your server is doing a keys, it will not be able to answer, and of course the sentinel will find out that the slaves are alive, and it will do a quorum, and you'll have a new master. But still, you'll have your master working, just doing some heavy stuff. And you might not find this, because you might not catch this in development, because you'll probably have just a few keys on the server. So you'll say, okay, well, it was pretty fast on my machine. But once you go live and you have tens of thousands of keys, hundreds of thousands of keys, things can go not that nice. What's also nice to have would be some in-memory introspection. Like you saw, you are using a lot of data structures, and if you'd like right now to find out how much memory one of those data structure is consuming, there is no way to find out. You can only find out on the whole server how much stuff it needs to store all the data structures. And it would be nice if you could find out about each structure by itself, because you could make some calculation and see exactly how much memory you are going to need when going live. You can estimate how many structures, how many items inside them, and you can easily extrapolate to make the calculations. Okay, so that's it about Redis. Moving on to Aerospike. It was created with being both fast and scalable. This is what they are saying. And it follows like a well-known pattern. Like, it has a community and enterprise edition, and of course for the enterprise edition you need to pay, and enterprise will come with some additional things. So you're paying for something and for support also. Also easy to start. You have it like a Vagrant box locally. This is how I have it installed. And on AWS and Azure, you can find it in the marketplace. You can find the community edition, and you can have a VM running in just a couple of minutes with Aerospike. A lot of companies are using it. For me, which I'm in the travel industry, Kayak, it's very well known. There are also some companies in the advertising that they need very fast things, something like this. Okay, now if you are starting to learn about Aerospike, you will find these things that doesn't have so many data structures comparing to Redis, just because it doesn't try to solve the live analytics issue. So they don't need so many data structures. Support with Lua, it's there. You can find it here. It's with user-defined functions. And I think its main power stays in its storage model. So you can have different storage models in the same cluster. And namespaces are similar to databases, but you don't need to confuse them with databases. They are just describing the storage model, something like this. So they're not a really database. It's just a way of encapsulating the storage model. So you can have on a cluster, you can have different namespaces with different storage models. Then you have sets, and sets are very similar to tables. And then you can have inside sets, you have records. And a set has also beans, and beans are columns. And here, beside the primary key of the record, you also have indexes that you can define on those beans. So you can have secondary indexes. And once you have secondary indexes, you can do query on those beans. Okay, now just a few words about the storage model. And you could have it in memory, no persistent at all, and probably if you find some benchmarks or stuff like this, you know that they use this storage model to be fastest possible. And you can have persistence, putting data on disk. But what's interesting is, and you'll not find in many other places, just one that I know, is they have a special storage model for SSD. And for SSD, the complicated part is when you need to update something. So the read and the write are very fast. But if you have an existing value and you need to update it, that takes a lot, a couple of times more than just doing a write on when nothing was there. And they have something like they're not deleting the data; they're just appending stuff to it. So this way, from an update, it's actually transforming to some write. But because of this, you should not mount that SSD. You should not mount it to the operating system. It should not have a file system because it will override themselves. So you need, if you're going to SSD, you need to be aware of this. On a restart or something like this, it will actually not start anymore, the server. And in this case, it only keeps the indexes in memory, so all the data is fetched and written to directly on the SSD, and it will only keep the indexes in memory. And this is the most nice part, is you don't need to consider the namespace like a database, but more like a way of defining the storage, how it will be saved there. And that's also because you can do backup of sets. Like when you have a database, you can do backup of the whole database. Here you can pick different sets and do backups of them. So you don't need that. Okay, so I have a small demo also on Aerospike. Do you have time for? Yeah, okay, good. Because I need to start the VM and it's going to take a little. So if you have questions about Aerospike, I will be glad to answer them. Hopefully it will start. So what will happen is I will add some things to the server, just like a few records inside the set, and I will try to query, and it will give me an error because there is no index created on the bin that I'm trying to query. After that, we'll see how it's pretty easy to create the index, and then I will just make the query again and it will work. Okay. So it has a nice interface, a management console. So you can see it here. So there is only one. It doesn't find any cluster. I have only one machine. No objects inside. Okay. And no replication factor because it's only one machine. And here. So now I'm just adding some stuff to it. And let me show the code a little here. So it gave me an error. I think it actually says query failed, index not found. Right? I think no, it can be seen. Okay. So now when we're going here, it comes default with a test namespace. And here I don't see the set, but we can see it here. The set, it's called, I just created some users similar to what I did in Redis there, job, company, city, country, and just saving them. Let's see here, here's how I'm saving them. And I'm putting here the bins, the columns. And the set is called users. So now I'm going to define the index on the email. No, sorry, on the city. Just to make sure. The query is on the city. So a new index. Yeah. City. Users. And the bin time is string. If I would create it numerically and I would have string, it wouldn't be any index, because you can have like a column where you can store strings and numbers, and if you define the index to be strings, it will only index only the string values, and the same with numbers. Yeah. So I'm just creating it. Now I will run it again. It will actually just update those records. This is the policy that I did when putting the, and you can have here the user that I defined it. It was from Belgrade. Okay. So if you have questions, if not, I will move to what will happen when you go live. So yes. Okay. What happens when you go live and you find the not so nice part? In the case of Aerospike, the replication is synchronously. They say that. So it's not hidden. No. So they don't recommend putting a cluster in different data centers because of the latency. You might have some network partition because all the big latency, the nodes will not find themselves. You can still, so in our case, it's not recommended even on different availability zones on AWS. So even if you are in the same region and you have, if you're using more availability zones, as you should, Amazon recommends if you have like some cluster, put different nodes on different availability zones. Because if some meteorite falls on one availability zone, the other availability zone is tens of kilometers away, so nothing will happen. And there were cases before when some strange things happen only on one availability zones and all the others in the same region were not affected. So this is their recommendation. But because Aerospike doesn't recommend it, it's not good to set up it like this. We actually did it, and you can change the configuration, all the timeouts and the settings, on how many timeouts to take that node apart. So you can play with these settings and modify them based on your latency. But if you happen to have some like network partition, in such a case, you need to restart the node that it's lost from the cluster. So if you are going to restart the node, it will not start very fast because it will need to bring all this data in memory. In our case, we were running on SSD, so normally data is everything on the disk, so it should be fast loading. But in SSD case, you have all the indexes in memory. So it still needs to go to all the records and build up all the indexes again. And this, in our case, took us something like 2.5 hours. They say it's at least 40 minutes to recreate everything. Of course, it's also based on how much data you have stored there. But the not so nice thing is that the Enterprise Edition has a fast restart, meaning that all the indexes are kept in the process memory, but they will also kept a copy in the operating system memory. And they use that copy, and if it's just a server restart and not a VM restart, they will be able to restart in just a couple of seconds. So that's for Enterprise. There's also the limitation of row size, maximum 1 mega, but they do explain it because so if you're going with SSD, you cannot have the whole record more than 1 mega. And the explanation is because you can index stuff. Yes? Please? It's already done, yeah. And just a few things more is a column name, so not the values inside the column. You cannot have it more than 40 bytes, and that's a little different than Redis that you saw. You can have really big keys there in Redis, if you remember. But here it's just because you are already inside one set, so you already have details about your metadata. So it's not for storing values, it's just for saying what will be there. So you don't need to use it like you're using it on Redis. And if you're going to SSDs, which is it still offers, even if it's not in memory, it still offers a very good performance. You need to make calculations on your indexes to fit in RAM, otherwise you'll not be able to create them. So these are the things that we found out going live with it. Okay, so this was all about it. And before we go to some QA, just to have like a small review. In memory, it actually means to have high performance, but it's also a key point for having a scalable application. And if you want to start using Autoscale on some cloud environment, you should really consider using some in-memory solution. And going with Memcached, this is a very simple API, which allows you to build a very good caching layer. Then Redis, you find it more filled with a lot of data structures that you can use, and now it's not immutable anymore. You can play around with these data structures and have things only in Redis, for example. While Aerospike, the main power comes from all the storage models that it applies. So you can have one cluster with things in memory, with things which are on disk, and with things which are in memory and disk persistent, something like this. So, okay. Now we can have questions, please. Yes, do we have a mic? No, try now.
Okay.
Great.
I saw that your company is using both Redis and Aerospike.
Yeah.
So can you tell me what was the problem that you come up to Redis and start using Aerospike? What was the exact problem that you were trying to solve and Redis didn't help?
Yeah. Why we're using Aerospike is we deployed with the SSD. So SSD and only with indexes in memory. And this allows us to keep a lot of stuff. I think we have a disk for around 1 terabyte. And we didn't want to pay the big amount that would take to host this in a Redis in memory. So that's why. Any other questions? If not, so if you want to find out more about Redis, we're using it for a long time now. You can ask me about the data structures, and please feel free to take a look at the GitHub where I posted that if you want to find out more how to use it. So thank you, and